The Richter scale is used for measuring the magnitude of an earthquake. The Richter magnitude R is given by this scary looking function right there, where E is the amount of energy in kilowatt hours released by the earthquake. Find the energy of the 3.9 magnitude earthquake that shook Wichita in 2021. Round to the nearest 100 kilowatt hours. Okay, big scary looking equation, but we only have two letters in there. We have R and we have E. They're giving us the magnitude, which would be R. We're going to solve for E. So let's plug in the magnitude that we have. They say we had a 3.9 magnitude earthquake for this particular scenario. So I'm going to change out R to be 3.9. 0.67 log. And I'm going to put that other stuff in parentheses here. 0.37 E plus 1.46. Okay, where is our variable? Well, it's tucked inside that log. That E is inside the log there, so we need to get rid of things that are not inside of that log. The easiest part to get rid of right now would be to minus off the 1.46. So let's start by taking away 1.46 from both sides. Since these decimals are somewhat friendly, I'm going to go ahead and just calculate what that would be. 3.9 minus 1.46 would get you 2.44. We still have 0.67 log 0.37e. Okay, what else is not inside the log? Well, 0.67, which is being multiplied to the log right now. So I'm going to divide 0.67 from both sides. 0.67, 0.67. So in this case, 2.44 divided by 0.67, that is not going to be a very friendly decimal. I'm just going to leave that little chunk alone for a moment and just kind of look at what I have. So that means I have 2.44 over 0.67 equals, just log now, 0.37e. Okay. I can't get rid of 0.37 because it's still inside of that log, and so is the e. So I need to get rid of the log itself. Since I have a log currently, its inverse operation would be its base. This log does not have a number down on the bottom for us to reference for a base, but remember that when there is a log that has no base number shown on it, that means it's technically log base 10 because it is the common log. So that means I can use a base 10 to exponentiate both sides. Big scary math words. We're going to raise both sides to an exponent and have the base of it be 10. So I like to just cheat and do a big fat 10 underneath these things. So it says 10 to the 2.44 over 0.67. It's like a wild fraction exponent. 10 and log 10 cancel out. If I rewrite what I have for a moment, I have, let me flip this around a little bit. 0.37e equals 10 to the 2.44 over 0.67 as an exponent. Excuse me. Last step, e is already fair game, so we can divide away 0.37. Let me make myself a little bit more room here. I wrote kind of big. Pardon the interruption. There we go. All right, I need to divide away the 0.37 from both sides. That'll at least tell me what I'm going to type in my calculator. Yikes, that's a weird looking exponent. Just be careful when we're typing this in here. It's round to the nearest 100 kilowatt hours, so let's get a couple of digits out of this here. I have 10 to the exponent 2.44 divided by, gosh dang it, divided by 0.67. I have that. Make sure you arrow out of it so it drops down, divided by 0.37 equals 11,846.47 yada yada yada. It says round to the nearest 100. So all right, 11,846. That'll at least be good enough. Round to the hundreds place, that would be the 8. 8 is next to a 4, so it's just going to be 11,800. So we'll say about 11,800 kilowatt hours of energy That's a lot of energy.